Today we're going to cover medians and altitudes of triangles. The median of the triangle goes from the vertex to the opposite side to the midpoint of the opposite side. So you find the midpoint and then draw a segment from the vertex to the midpoint. The center constructed from the medians is called a centroid. So the centroid is the intersection, it's a point, of the medians. So in this picture here, P is the centroid, it's the intersection of the medians. The medians can be drawn as segments or lines. One of the things that we have to remember about the centroid is that it's 2/3 of the distance from each vertex, which makes the remaining part 1/3. So in other words, this portion right here, AP, is 2/3 of AK, and then PK here is 1/3 of AK. So the centroid is 2/3 the distance from each vertex. To the midpoint of the opposite side. So the centroid is the intersection of the medians. The centroid is 2/3 of the distance from each vertex to the midpoint of the opposite side. So looking at our picture, AP is 2/3 of the median, which is AK. And PK would be the remaining 1/3. In triangle XYZ, P is the centroid and YV is 12. So this whole distance right here is 12. We want to find YP and PV. YP is going from the vertex to the centroid, so YP is 2/3 of 12. So 3 goes into 12 4 times, so this would be 8, so YP is 8. PV is 1/3 of 12, and that would be 4. Another way to think about this is you could have taken 12 in the first place, divided it by 3, which would give you 4. So each 1/3 of the length is 4. So that would give you PV is 4. This would be 2/3, so that would be 2 times 4, which is 8. So either way that you think about it is fine. In triangle ABC, G is the centroid, and CG, here, CG is 4, and we want to find GE and CE. So CG is 4, and CG is equal to 2/3 of CE. So 4 equals 2/3 of CE. Multiply both sides by 3, you have 12 equals 2 times CE. Divide by 2, and you have that CE equals 12. Divide that, you have CE equals 6. Divide that by 3, you would have that GE equals 2. Another way to think about this is you know that CG is 2/3. So if you divide 4 by 2, you would get that 2 equals 1/3, which is an easier way than looking at doing it with the equations. In triangle JLN, P is a centroid, PM is 6. We want to find JP, and then the whole length of the median, JM. Well, if PM is 1/3, we know that JP is 2/3. So JP would be 2 times 6, so JP would have to be 12. If I add all of them together, 12 plus 6, that would make JM equal 18. The altitude of a triangle goes from the vertex to the opposite side perpendicular. So it's a perpendicular from a vertex to the opposite side. The altitude can lie outside of the triangle. In the first picture, the altitude lies inside of the triangle. It goes from the vertex to the opposite side, perpendicular. It doesn't bisect it. Sometimes it will, but in most cases it doesn't. Sometimes we have to extend a side to find the altitude, which is going to lie outside of the triangle. The orthocenter is the intersection of altitudes. So P here is our intersection, and it is of the altitudes. So the vertices of ABC are -2, 2, 4, 4, and 1, -2. And there is a diagram for you right here. We're going to find the coordinates of the orthocenter, and these are the steps that I would like you to take. It helps you review all the algebraic concepts for equations of lines and slope that you will need for next year. So the first thing we're going to do is we're going to choose a segment, and I choose, or one of the sides of the triangle, and I choose BC, and we need to find the slope of BC. So the slope would equal, BC is 4, 4, and 1, -2. The slope, -2 minus 4 over 1 minus 4, which is -6 over -3. So the slope is 2. Then I want to find the equation of the line through point A, which is the vertex that's opposite BC, that's perpendicular to BC. So if the slope is 2, the slope of the perpendicular line is going to be -1/2. Point A is -2, 2. So I'm going to use the point slope form to find that equation. So y minus 2 equals -1/2 times x minus a -2, so x plus 2. Distribute, y minus 2 equals -1/2 x. -1/2 times 2 would give us -1. I will add 2 to both sides, so I have y equals -1/2 x plus 1. So the equation of the line that we have is y equals -1/2 x plus 1. So the y-intercept is 0, 1. Our our slope is -1/2, so down 1/2, up 1/2. So there's our first line. Then I'm going to choose the line or the segment or the side, whichever one you want to call it, of AC. The coordinates of A is -2, 2, and C is 1, -2. I find the slope. So -2 minus 2 over 1 minus a -2. So -4/3. That's our slope of AC. I want to find the equation of the line through point B that is perpendicular to AC. So the perpendicular slope would be +3/4. We're going through point B, which is opposite AC. This is the vertex opposite AC. And the coordinate for point B is 4, 4. Using point slope, we have y minus 4 equals 3/4 x minus 4. Distribute 3/4 x, and then 3/4 times -4 would give us -3. Add 4 to both sides. So now I have the equation equals y equals 3/4 x plus 1. So our intersection here, y intersection is 1, 0, 1. Our slope is down 3, 1, 2, 3. Excuse me, down 3, 1, 2, 3, 1, 2, 4, up 3, 1, 2, 3 over 4. So that's our other median. We don't need to draw the third median. Looking at this, we can see that the y-intercept is 0, 1, and that's where it crosses through both of those. But if we didn't have that case, the way we would solve it is that we would have the two lines. We have the line y equals -1/2 x plus 1, and we have the line y equals 3/4 x plus 1. We know that y equals y. So we set the two equations equal to each other. So -1/2 x plus 1 equals 3/4 x plus 1. I want to get rid of the fractions, so I'm going to multiply both sides by 4. 4 times -1/2 would give me -2x. 4 times 1 plus 4. 4 times 3/4 is 3x. Plus 4. Subtracting 4 from both sides, I have -2x equals 3x. So I would have 0 equals 5x. So x would have to equal 0. So the intersection point would be 0, 1. So doing this again, there's going to be times that I'm going to ask you to graph it, then find the midpoint, find the equation, find the midpoint of another side, find the equation, and set the two equations equal to each other. So first, let's graph this. We have h equals 0, 1. We have I equals 4, 3. And we have j equals 2, 5. So there's our triangle. First step that I want you to do is to find the midpoint of ij. So finding the midpoint of ij, we have the points 4, 3 and 2, 5. Finding the midpoint, we would add the x's, divide by 2, so we're averaging the x's and we're averaging the y's. So our midpoint is 3, 4. And that's the midpoint of ij, which is right there. Then find the equation through the midpoint you found, which is 3, 4, and point H, which is 0, 1. So it's the vertex that's opposite it. So the first thing we have to do is find the slope. So 4 minus 1 over 3 minus 0 is 3 over 3. The slope is 1. We already know the y-intercept, so our equation is y equals, our slope is 1, so 1 times x is x plus 1. And that would give us this line right here that goes from this vertex to that. Next thing I want you to do is to find the midpoint of HJ. So H is 0, 1, and J is 2, 5. So average the x's, average the y's. That gives us 2 over 2, which is 1. 1 plus 5 is 6. 6 divided by 2 is 3. So that's our midpoint. We want to find the equation of the line through that midpoint that we found, which is 1, 3, and point I, which is 4, 3. First thing is to find the slope. So 3 minus 3 over 4 minus 1, which is 0 over 3, so the slope is 0. Once we see the slope is 0, I look back at the equation and see they both have a y that is 3. So the equation here is y equals 3. So looking back at our picture up here, we found the midpoint of HJ, which was 1, 3, which is right here. Looking at the picture, we can definitely see that this would go through this right here. Here's our centroid. To find the intersection of the two lines, we have y equals x plus 1 and y equals 3. We know that y has to equal y, so 3 equals x plus 1, so x equals 2. So we have x equals 2, we have y equals 3, so the intersection point is 2, 3. And that concludes the lesson for 5-2, medians and altitudes.